In this class, we want to prove a very important property of beta function, and the important property is beta mn, this is equal to beta nm. That is, the beta function is symmetric about its two parameter m and n. Right? We first write the definition or the expression of beta function, and which is given by beta mn. This is equal to integration 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 dx. Right? And in the chapter of improper integration, we already proved that beta function is convergent only for m greater than 0 and n greater than 0. So we write here is convergent for m greater than 0 and n greater than 0. Right? Now if we put in this integration x, this is equal to 1 minus y. Okay, so we get dx, this is equal to minus dy, and the limit of x and y are respectively, the limit of x are 0 to 1 and the limit of y is 1 to 0. So this integration beta mn, this is equal to integration 1 to 0. We put the value of x here, and this is 1 minus y to the power m minus 1 into 1 minus y to the power n minus 1 into minus dy, and this is given by integration 0 to 1. We interchange the limit of the integration and cancelling the minus sign. Okay, this minus and this minus will be plus, and this term we write first, this is y to the power n minus 1 and this is 1 minus y to the power m minus 1 dy. And clearly from the definition of beta function, we can write this definition as beta nm. Okay, so we proved the result that beta mn, this is equal to beta nm. Right. Also, this beta function can be written in another form, which is given by, we put here in the first form x, this is equal to 1 plus 1 by y. Right? Then dx, this is equal to minus 1 by 1 plus y whole square dy, and from this relation we get 1 plus y, this is equal to 1 by x, and y, this is equal to 1 by x minus 1. So we interchange the limit from x to y, limit of the integration is 0 and 1, so the limit of y is infinity and this is 0. Okay, and we write beta mn, this is equal to integration infinity to 0, and from here we get the value of x is 1 by 1 plus y whole to the power m minus 1 into 1 minus 1 by 1 plus y whole to the power n minus 1 into the value of dx, this is given by minus 1 plus y whole square into dy. Right? And calculating this integration, we get the range is 0 to infinity because we reverse the range of integration and cancelling the minus sign, and from this relation we get, this is y by 1 plus y whole to the power n minus 1, and from here we get 1 plus y whole to the power m minus 1 into 1 by 1 plus y whole to the power 2 dy. So this is integration 0 to infinity y to the power, this is y to the power n minus 1 by 1 plus y to the power n plus n dy. Okay, and this is beta m. And since this relation is beta mn, we can write this is equal to beta nm also. And from this type, we can also write integration 0 to infinity. This is y to the power m minus 1, because in place of n we write m here, and 1 plus y whole to the power n plus m dy. So we get three alternative definition or three alternative form of beta function. The first one is this, and the second one is this, and the third one is this. These three are equivalent and the value of these three functions are same. But actually this definition, that is the first definition of beta function, is also known as beta 1 mn and is beta function of first kind with parameter m, n. Okay, and these two definition is known as beta 2 mn, that is beta function of second kind of with parameter mn. Okay, and all the beta functions are convergent for the same condition. This is n greater than 0 and n greater than 0, right? And that is the today's class. Thank you for watching.